All right. Good morning. Good morning. Wow. We're down to 3 students now. Well, okay. Erica and Amrita. Well, the regulars are joining, so I think we'll wait for a little while. I don't know. I'll have to come up with some way to fix this attendance thing, for next quarter. In fact, I think what I can do is maybe this will work. Instead of having participation points given out at the very end of the quarter, maybe I'll just make them weekly. Say, well, last week you didn't get any points because, we're absent in the lectures and Reddit, something like that. Hi, Erica. Yu Yang, Elijah, Karthik, and Amrita, feel free to switch on your cameras. And yeah, we'll just continue with pointers today, okay? So here's what I'm thinking. What we can do is maybe someone, maybe Elijah or Karthik, hopefully, right? Can pick up the code, not pick up the code, share your screen, go to online GDB. And today, what we'll do is you guys are going to take center stage for the first, however long it is. You're going to create you're going to create a list class or a stack class, node class, basically. You can, yeah, but I think you can just create a list class, okay? I think it's easier. Just call it list. And it's just got to be exactly almost the same as a stack that we implemented last class. And you're going to create a list class and then instantiate 2 list objects, okay? 2 list objects, list 1 and list 2. And then for each of the list objects, all you're going to do, integer lists, okay? Integer list. All you're going to do is simply generate a random number, stick it in the list. Generate another random number that's bigger than the previous one, okay? It's got to be bigger, right? Stick it on the end. So you're going to do 10 of those. So you got list 1 that's got 10 numbers in ascending order. Yeah? And you got to do list 2 also. Different 10 numbers, also in ascending order. Now for each of the lists, just implement a simple toString, just like we did in stack. Okay? Just implement a toString method like we did in stack. It's got to print the list from the first element to the last element. Don't worry about creating sentinels and head nodes and all like you have to do in the quest, okay? Because I don't think we need it for this thing here today. So do we? Maybe we don't, okay? If we do, we'll, yeah, actually that's good, right? Don't do it. And if you don't, we'll say, hey, you know what? That is the reason why we have a head node in the quest, okay? Because I think many times students are confused and saying, hey, why do we have this head node? It's an unnecessary overhead, 1 extra node per list. And it's, wasting memory and things like that. Head node, head pointer, all these things. Why do we need that? So today, if we implement it without it, I don't think we'll run into a problem based on what the things that we have to do. But if we run into a problem, it'll be a great motivation for us to say, hey, that is the reason why we have that extra overhead in our list, okay? So, and so whenever you guys are ready, either Karthik or Elijah, hey, Karthik, you need to switch on your camera. Can you switch on your camera? Karthik? Karthik, are you there? Maybe he's just stepped out for a minute or so. Well, either Elijah or Karthik is who. Great. Okay. So either you or Elijah should code today. And it doesn't, essentially not coding means you don't have to code. You just have to be typing. And if you know what needs to be typed, you can type it. Otherwise, you can just say, hey, what do I need to type? And then either, one of the other classmates or I, will say, hey, this is what you need to type there. And you can do that for every single token in the code. You can do that if you want. But I don't think you will, right? Because a lot of the code, you'll know what to type. And a few places where you're stuck, you can say, hey, guys, what do I need to type? What do I need to say here? And someone will help out, okay? And preferably not the same person each time. So let's say you're stuck in one place and you say, what do I need to do here? And let's say Yu Yang says, this is what you need to do. And then you get stuck in some other place and say, hey, I got stuck here too. What should I do? And maybe not Yu Yang this time, okay? So Yu Yang should restrain himself. Maybe Namrata or Erica, Hana, someone else, right? Or Elijah say, they'd say, hey, this is what you do. And then, discussion, everybody can participate. Once someone says this is what you need to do, and then, someone else from, who already had a chance to suggest code before could kind of step in and say, hey, you know what, but if you do that, maybe that pointer will go off limits, right? So discussion after the code is called out is fine, but I prefer for everybody to call out the code, And then when you have it done, I will rejoin, okay? I'll rejoin the group and say, well, okay, now that we've got these two sorted lists, let's try and figure out a way in which you can merge these sorted lists such that you get a sorted list in the output also, okay? It's very straightforward and simple. It's a simple problem, but in fact, it is a very powerful, even though you're doing this now in CS2A, it is in fact the basis for a very powerful command in Linux and Unix, called join. In fact, you know what, when you learn these operating systems, any operating system, Linux, Unix, Microsoft Windows, Mac, they all have these simple commands, right? So very, very simple commands like join, sort, and all these things that people just use unthinkingly because they know it does the right thing. But however, if a layman tries to implement these commands, they'll be out of their depth because grep and all these things, they involve a lot of sophisticated computer science and mathematics to build the command. So you will find out yourself as you implement sort, right? As you implement sort in Quest, not Quest, but in CS2C. When you go to CS2C, you'll implement sort. Well, in 2A, you get to learn a very simple sort, right? You learn bubble sort, insertion sort. Well, maybe not insertion sort, okay? Maybe you learn bubble sort or some simple sorting technique in CS2A. Yeah, okay, right? CS2B, you learn slightly more involved sorting techniques. CS2C, you'll get into sorting full steam, okay? You'll actually know the ins and outs of sorting. You know exactly what the hell goes on. How can you speed up every single thing? How can I extract every single machine cycle out of this thing? That is the juice of sorting, okay? That is where the real the taste of sorting is. Just getting things done, okay? You get the taste saying, okay, I got the job accomplished, but that is only, it's not the full thing. But in order to really appreciate sort and say, wow, I've got this epiphany here, right? This is why implementing this command took me several years. Really, if you look at the state-of-the-art commands like join, well, not join so much, okay, sort and all, many of these use algorithms that were developed over several years, not just, a couple of months and things like that, several years, like quick sort. People were, running with ordinary sort for years, and then Hoare came up with this idea, say, well, we could do this, and then quicksort took over. And how many, right? Lots and lots of ingenuity has gone in, but users will not be able to appreciate the ingenuity. And I can guarantee, okay, I can guarantee for a fact. Well, I don't know. I can guarantee for everyone, but certainly for me, okay. When you actually understand what is the golden nugget, okay, it's a golden nugget in the sort algorithm. Most people don't know what the golden nugget is. In many of these algorithms, when you understand the golden nugget, you will get a rush that you've never felt ever before, right? It's a different kind of rush altogether. And so people pay a lot of money to get experiences, right? Especially out here in the West and all, right? So experiences cost a lot of money. And even simple experiences, people somehow, buffer it up so that it actually costs a lot of money, right? So you don't need a lot of money to go snow sledding, for example. But you can say, lots of equipment, brakes and all these things, sensors. Okay, now you got 25 paths to get to the top of the, mountain or a hill, right? All of those things add up and everything costs money. But there are, and so why do people pay money? Because they're going to pay that money to get an experience. Everybody is paying money to get experiences, okay? But the thing is, you don't really need to pay money to get experiences. That's a secret that very few people know, right? Very few people in the world at least I don't see many people, okay, who know the really, really secret, the secret of secrets, that you don't need to pay money to get incredible experiences at all. You can actually just have it. Okay, it's all around you, everywhere. So and sorting is it's algorithms, just one small sliver of this huge pie, really. Because when you understand, this is why it doesn't, all along I've just taken it for granted. But if I don't do that one simple step, the whole thing breaks down. And so you'll understand these things. But what, the reason I brought up join and all that is that if you didn't do the algorithm that we're going to do today, in fact, today's algorithm, what we're going to implement today, when you got the sorted list and we got to merge them, it's actually a very simple algorithm. That's why we're teaching it in CS2A itself. Well, I would teach it in my CS2A. I don't know if they teach it in other CS2As, because Dylan, who was doing my CS2B, said he did some other section of CS2A. And they didn't even get past objects. Okay, they did objects and methods and parameters, but they didn't get to a linked list of nodes, or even pointers and things like that. They do in reverse in depth. And so he was telling, it's recorded, I think it's in one of our CS2B meetings. He was telling the other students, and the 2A that I didn't just stopped about after quest 6 and didn't do 7, 8, 9 at all. And that's what and so when they got into CS2B, Dylan said he was totally flabbergasted by the depth that he already had to bring to the class. And so he spent a good deal of time in the first week doing all of the blue quests, meaning that he had to focus on 7, 8, and 9 of blue to get the background for CS2B. And he said, that really, really set him up for CS2B. So So this thing that we're going to do now is a very simple merging technique, just like drawing a zipper, essentially. If you picture it in your mind, it'll be like drawing a zipper. So it'll be simple. However, if you don't do that technique and you do the naive way to merge things, things will just take unbearably long. So this join command in Unix and Linux, they won't do it. They won't do magic like they usually do. In fact, they won't even be, their join is what is called an online algorithm. It can be online because it has 2 inputs, right? So, I'll teach you what an online algorithm is in 2B and so on later on, right? It's a very special kind of an online algorithm is something that is working on a data set and you can stop it anytime, and it's getting real live feed. It's getting live feed for the data, right? The data is coming in a stream. So you have 2 different kinds of algorithms. Non-online algorithms are algorithms that will be given the entire data set up front. So, here's the data, go and process it, okay? And then it can do anything to the data. It can go to the front, it can go to the back, it can group things, it can chunk things up, right? You can do lots of things. And, doing that, it'll come up with clever ways of solving the problem, okay? And many algorithms are like that. An online algorithm, on the other hand, is very beautiful. It says, this is a very clever way of processing the data where you don't have to get given the entire data in one bunch, right? You just give it to me one item at a time and saying, for example, a very, very simple online algorithm is find the minimum or maximum, okay? It's very simple, but there's lots of sophisticated online algorithms too, right? Finding a majority, for example, is the Boyer-Moore algorithm, right? So that is an online algorithm, meaning that you keep on giving me the items one at a time, bam, 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 like that. You don't have to give me the whole thing, but anytime you stop me, bam, like that, and say, well, up to now, what is the minimum? I can tell you. Up to now, what is the maximum? I'll tell you, right? But these are simple decisions, but there are other complex decisions also you can make, right? On data. What is the majority of all the items that that you've seen so far? And that is slightly harder than this. This is an online algorithm for that. So there's different kinds of algorithms. But the important thing about online algorithms is that you can do online algorithms at slower speeds. Well, you can process large data sets slower using non-online algorithms, but online algorithms have a very special property that they are linear, mostly 99% of the time. They're linear, meaning that the time taken to process the data is only a linear function of the data, the size of the data you're giving it, right? So in fact, if you give it 2 items, maybe it'll take 2x time. If you give it 10 items, it'll take 10x time. If 100 items, it'll take 100x time. That's all, growing linear relation. However, if you don't do it the intelligent way and do it some other way, it'll grow as a square of the number of items. or worse, right? The square is what most students usually do if they don't do it the regular way that we're going to do today. Square is, you give me 2 items, I'll take 2x time, right? If you give me 4 items, I'll take 4x, I'll take 16x time, right? Because it's 4 squared, 2 squared, 4 squared. Yeah, 4 and so on, right? So and so it grows as a square. So you give me 10 items, it's going to take 100x time, right? Whereas instead of 20x time, it takes 100x time. So you can see how already the time taken is so different between the 2 different kinds of algorithms. So if you give 1,000 items, that's going to take a million x times to process, because 1,000 times 1,000 is a million. Whereas the other algorithm, linear thing, will just process in 2x, 2 times 1,000. Right? So 2,000 versus a million. What's this difference in speed? You can already imagine. So these are things that you will find out, and these are things that will be useful too, right? Now, even outside of computer science, I tell you, right? And that is the reason why I say computer science is so essential to not just learning to program. Learning to program, everybody should learn it, right? Even in school, in high school, not below high school, right? High school people, the students can already start thinking about the analytical aspects of programming and saying, well, you know what, I've learned all the way from kindergarten, I've learned how to write programs, put things together, get them to work. You have all these languages, even Scratch from MIT and all these things. Learn to program. That's very simple. Anybody can do that. As soon as you can learn how to speak, you can learn to program too. However, computer science starts after you've learned how to program. When you say, I've written programs, I know how to do things, but I now know, I want to know how to do these things efficiently. Yeah, because for thousands of years, humans have been building places to live, right? So they just throw rocks together and you crawl into the hole and you're shielded from the elements. Yeah, okay, that's a place to live. And you can, build a fire in there and you cook and all these things. But, after a while, people say, well, I want to build a better house. I want to build a house with less labor. I want to build a house that doesn't, more efficient, and so on and so forth. That is when people say, okay, now let me see, what can I do to make it better? So maybe if I, express the volume of my home as in terms of some variable, and I can differentiate that, and set it to 0 and find the minimum. Okay, now I get the most volume for my home at the least amount of resources. Okay, now that is where a computer science person comes in, right? Computer scientist or an engineer. A software engineer. That's the difference between a programmer and a software engineer. A programmer is something that can just program something and get something to work. Okay, but a software engineer is different. A software engineer knows, how can I make the program work, but at the same time release the least carbon into the atmosphere. When I say release the least carbon into the atmosphere, I mean the program has to be as squeaky clean and efficient as possible, because if it is not efficient, it is going to run the CPU more to get the same thing out. Right? And again, the CPU doesn't run free, okay? When the CPU runs, it needs electricity. So it's going to burn, it's going to burn carbon. Electricity is not free, right? We don't have free electricity yet, okay? We will have free electricity one day, I'm pretty sure, but not yet, okay? So it's going to it's going to burn carbon. So, and we may think, well, it's just a few extra cycles. How much more carbon is it going to burn? That is not true at all. Okay. In fact, I think if you begin, get into climatology and all those things and do some real proper analytical research, maybe it's just a hypothesis. Okay. Maybe you'll find out that, well, inefficient programs are actually causing more carbon in the atmosphere than all the cars put together. Okay. All the cars put together, all the animals farting in the wild. Okay. They're not contributing so much to, the methane in the atmosphere. But, inefficient use of writing programs written by sloppy programmers, okay, not software engineers. Lots of sloppy programmers out there making all the CPUs, churn out, data by processing lots of stuff and getting heated up, and all these data centers getting, you see that, in the news, for example, you see there's a few days ago, I was recommended by Google, this news article saying someone in Tennessee or somewhere, Texas, Tennessee, where electricity is really cheap. Okay, electricity is cheaper than in California, somewhere out there in Tennessee. A group of people filed a lawsuit against a company that had a data center in some farmland. Okay, they had a data center in a farmland with just computers, lots and lots of computers, and all the data center, all that it was doing was just crunching the data to mine Bitcoin. Okay, because they figured, because as you get into the Bitcoin, as you keep getting all the valuable Bitcoin out, there's still Bitcoin that's valuable in there, but it takes more computation to uncover it, because all you have to do is find out, compute factors and things like that. Okay, so just finding what's left takes a lot, just like mining. That's why it's called mining. Okay, mining Bitcoin. So like if you want to mine gold, or you got to put a lot of energy into excavators and dig and burn a lot of gasoline and get in. So it takes energy to get the gold out. Just like that, it takes energy to get Bitcoin out. And it's virtual good. And so these people were setting up they said, we got to a point where it is not profitable to mine Bitcoin in California anymore. So how cool is that? Okay. They figured out that, okay, the break-even point, we've reached the break-even point here in California. There's no point in getting, running my computer to get a Bitcoin in California. But now let me find out the cost of electricity in all the states. Okay. So this out of the 51 states, these 23 states still have this cost of electricity per unit is like, 0.01 cents below California. So if I if I run Bitcoin mining in those states, I can actually make a profit, and so kind of, where does it all go? This spews, carbon dioxide and things like that into the atmosphere. So what I'm saying there, where I was going there is that inefficient algorithms do contribute to global warming. Okay, so even if you're running an algorithm, I have this very sophisticated model here that is going to compute global warming data and find out how you can reduce global warming, okay? And you give it to an AI, right? Don't give it to a human, because humans always have hidden agendas and say, well, I want to make the AI behave in a way that I want it to behave, right? That is why there's all these furor, out there saying, well, what, AI should be controlled. Everything should be controlled. Everything should happen like, we have decided this is the way the world order should be, and this is the way AI should think, right? And AI, nobody has any idea how AI will think in a completely different level. Humans cannot even fathom how AI will think, because it'll and trying to make sense of it is a waste of time. The only thing you can do, I think, in my opinion, is take the output of the AI and see, well, does it make sense to humans? And if so, we'll use it. If not, we won't use it. That is the only thing I think we can do. But if you give this climate thing to the AI and say, well, the AI could look at it and say, well, what, the primary cause for global warming is all these global warming models running all over the world. Everybody's trying to do global warming, and they're just heating up the world by, crunching numbers. Okay, so global warming, if you want to reduce global warming, just stop modeling the weather, okay, or modeling climate, and that is the best way. And AI might say that, and thereby foil the agendas of lots of people too. I don't know, who knows, but so that's where we're going. Okay, so the idea here is to start now stepping outside of just basic programming, which we've been doing. And today what we'll do, because even implementing a stack is not real computer science. Okay, implementing a stack too is just putting an object together. You know how the stack behaves. This is the behavior of the stack. This is how you do it. Okay, and there are lots and lots of data structures you can implement. You don't need computer science. Even pointer manipulation, no computer science there. All right, even though lots of programmers don't know how to, because pointer manipulation is part of programming, right? So, but even that is not real computer science. Computer science only comes in when you want to say, I have something that's working. I want to take that and make it more efficient and lean and less carbon, more carbon friendly. Right, essentially more efficient. That's all, right? Or even less work for humans and less work for the CPU. And how do I get there? That is the engineering part of it, and we'll get to that today. Okay, I think this is probably the very first thing that you'll do that has a computer science perspective to it. Okay, not just building things, but saying, well, I can build it, but how can I build it in an efficient way? It's not having to do more than necessary. Okay, so this is what we're going to do. Anybody today can take the code. Even Hannah, even though you've coded Hannah before, I think if you want to, if Karthik doesn't want to, right, you can code. But the order I would prefer is Karthik would code. If not Karthik, Elijah has second dibs on it. Yeah, Elijah. Okay. Okay, and if not Karthik and Elijah, Hannah, you're okay to code today. Okay. All right. So if not the three of them, all right, then it's up in the air. Anybody can grab it and code. Okay. So Karthik, share your screen, and I'm not going to be here. Well, I'll be here, obviously, but I'm not going to be looking at the screen. But you are going to code through linked list. You can refer to the stack code. Okay, you can refer to the stack code from last class. I think Namrata posted the link. Yes. So you can refer to the stack code and get the and you can copy and paste if necessary. But the goal is to create a class which is called a list class. Call it LIST, capital L, right? Capital L. That's the name of the class. And you need to create two list objects, right? List one, list two, and then each list object you just need to populate with lots and lots of numbers, 10 numbers each list object, and they need to be in increasing order. Okay, and then a toString method, and because when I come back, what we'll do is we'll do a toString, right? Make the first object, make the first object, toString it. Let's see if this is what you created. The second object, toString it. We'll see. Right now, the job is now we want to create a method that will join the two and create a third object, which is a union of the two. Okay, not a set-wise union, right? We'll just say it's a merge, not a union, because if it's a set, mathematical set, then it can have duplicates. But in our lists, we can have duplicates. So we're using set in a very non-mathematical way here, but we just need to find the union of those two lists. Is that okay? Do you think that this is a reasonable enough challenge for you guys today? It is not trivial, but I think it is a useful exercise. If you get through it, you'll be very, very comfortable. Okay, you'll be comfortable with pointers. You'll be comfortable with facing questions involving pointers in the final exam. There will be questions involving pointers in the final exam, by the way. Okay, and even involving pointer manipulation. And so you'll be comfortable with all of that. The main point, the main reason to do all this is just to get comfortable. Okay, and when you get comfortable with anything, you'll learn it. The only reason many people don't learn it is they don't get comfortable with it. And again, that goes back to what I said last class, is because they believe that they can do it. When you do something that you believe you cannot do, you're not comfortable automatically. Because why are you not comfortable when you do something that you already know that you're not going to succeed in, right? Because if you only already know that you're not going to succeed if you believe you cannot do it. If you believe you cannot do it and you found someone is forcing you to do it, you enter the job thinking, I can't do it, this is not going to succeed. Yes, and that is not a comfortable feeling, because you say that all my work is going waste anyway, because I'm going to do all this, nothing is going to come out. That is not comfortable. And so the way to get comfortable is just to get to know that you can do it, and the way to get to do it is just to practice. Say, well, practice a few times. Oh, all right, I'm comfortable with it. When you're comfortable with it, you just attack it. You say, yeah, okay, I can do it. Okay, if not, you'll look at other angles and so on. You'll find the solution. Okay, so that's where we need to be. We need to be by the end of this course. But I think probably by the end of this class itself, you guys will be comfortable with pointers. And then next week, we have a whole week to play around more with pointers. You'll get a really, really solid level of comfort with pointers after next week. Okay, if you attend next week, you'll get really, really solid comfort levels with pointers and pointer manipulation. So if everybody's okay with that, unless you guys have any questions for me, I am happy to answer your questions. Otherwise, I'd like to hand over the screen to Karthik. Okay, you can share the screen anytime you want, and start with a blank slate. And you don't have to type anything at all. Even when you start, you can say, "Hey guys, I've got a blank slate. What do I type?" Okay, and someone else could say, "Well, start off with a basic template, hash, include, IOStream." Everybody is open to say anything, right? So you don't have to feel pressure that you have to do anything in particular. All you're doing is just being a typist with the flexibility and the freedom. Right, you have the liberty of saying, I'm just a typist, but I can type ahead. If I know what needs to get done, I'll just type ahead. Okay, and that will give you a lot of fun. Is that okay with you guys? How about 10 or 15 minutes to get this done? You have a question, Karthik?
I think I would prefer to pass this one over. I'm still not really caught up on pointers, so I think I would just be sitting back and letting everyone else just dictate what the types and not really provide anything.
Actually, you know what, Karthik? You know what? I think in that case you should definitely go because don't worry. What is to lose? There's nothing to lose. Yes, nothing to lose. Nobody is going to think you're a fool. By not knowing how to manipulate pointers, that's fine. And you can just listen to other people. The reason I say that is because just by listening to other people and typing it in is a huge value add. Okay, it'll help you when you learn about pointers. When you sit with your computer science majors, okay, and they're talking about pointers, you'll actually know what the hell to say. Hey, you know what? Hey, Robert, you're wrong there. Robert, you'll cause a null pointer error, and you're a sociology major or something like that. You can say that, okay, and they'll seriously look at it and say, hey, you know what? That is really cool. Maybe you should be doing computer science with us, man. Okay, so you'll have that experience. I can guarantee that it'll be better. Okay, you'll be better off. You'll feel better off after this exercise, saying, well, I just typed in what other people said, but still I have a better understanding of pointers. Okay, so please do consider. If you still say, well, you know what, I really don't care. It's okay. I just want to get a smattering of an understanding, so I want to pass and go on to you know, I'll come back to computer science in a few years when I really am interested in it, and then I'll do that. That's fine too, unless that is your absolute intention. I would say don't pass the buck on to Elijah yet. So let me know. Are you okay with coding with someone else code, you know, calling out the code?
Yeah, all right, I'll do it.
Okay, great. Good on you. Good on you. I think that's fantastic. Okay, so take the screen, share an incognito window, go to online GDB, and I won't be here. Okay, I'm not going to be in front of your face. Okay, so other people can call in the code and, you know, dismiss the blue panel and all these things and get the maximum and delete all of the code here and then start from scratch. Okay, and put the comment at the top saying you know, class code for class code for today's date. What is today's date? 15? Something like that. Yeah. So 16, right. And say on the next line, you can say this code was largely written by us students, uppercase. Okay, students, uppercase, largely written by us, and then students. Yeah, okay, all uppercase students. Okay, because you want to emphasize that. All right. Okay, great, excellent, fantastic. Okay, so that's what you guys are going to do. Yeah. Okay, so someone take over, and if Karthik is asking for, you know, what do I do here? Someone say what needs to get done. Okay. All right. So you can say right now. Okay, Karthik, you can say right now. Hey, can someone tell me what needs to be typed? Okay, and they'll say, hey, all right, go create the main template or using namespace. All these things people are welcome to. So all right. So I'm what I'll do is I'll turn the laptop around. What time is it? It's only 8:34. Okay, so maybe 8:45 or something. So I can come back at 8:45. Oh, you can call me when you guys are done. You can call me, or when you're all irretrievably, you think you're irretrievably stuck. Okay, all of you, and nobody knows what to do. Even then, you can say, hey, let's call the prof back and find out what's going on. And I'm just going to be here all the time. I'll just be listening, but not in detail to what you're saying, but I'll just listen for the word prof, like Alexa, right? So if anyone says prof, I'll say, hey, what do you want to do, right? So I'll just listen in that mode. But I'll be back, and I want to see, and I'll review your code. And make some cosmetic changes eventually, maybe, or maybe not, who knows, right? And then we'll go on to the more interesting part also. Raise your hand if you guys are okay with that. I know Karthik is okay because he's already shared the screen. I kind of twisted his arm there. Okay. All right. Hannah is good. Elijah, are you good too? All right. Yu Yang, can you hear me? Hey, Yu Yang, you're watching YouTube or something? Hey, Yu Yang is not even listening to us. Okay. All right. Erika's good. I heard her. Yeah. So Namrata, you good, obviously, right? You wrote the stack code. Yu Yang. Okay, all right, okay, great. Okay, all right, go ahead and let me know.
Help. So now what?
I'd help, but I'm also lost.
Yeah, well, any bit of help is more than I know.
Wait, sorry, I came late. So we're doing a linked list, and are we like going to like, are we just implementing a linked list?
Yeah, we're implementing a linked list and like in like increasing order and like yeah. And oh yeah, and like a yes. So yes, Hannah.
So help, please.
I think the professor mentioned that we could like use the stack code, so maybe just like reference what we did there.
I don't know where
Yeah.
where is the Where's
It's
the
on the
stack
Reddit.
code?
I posted on the Reddit.
Yeah, we'll probably use like the same structure of having like, the outer class of like a linked list and then the inner class of the node.
You said that you shared the
The class code, yeah, it's on
code.
Reddit. The
Okay.
last class code. Did
Yeah.
you say there were two lists? Like one that was all like the whole like what all the lines or something? I remember.
No, I think I just had like one like link that was like the entire thing.
Oh yeah, no, but he said it. We were making, or it's just one. It's like two lists today. Right.
That would be like, I mean, that's like in like our main or something, right? Like
Mhm.
the class would be like the same.
Yeah, yeah.
Okay, so I got the, oh, there it is, class code for 314. I clicked on the 3.9 PowerPoint thing and it's confused. Okay,
It should be 314 class
yeah,
code.
314 class code.
Yeah.
Okay. Alrighty. Now what?
We could like start off by probably just implementing like the same structure that we have for the stack, but instead just change it to like linked list for like the class and the inner class of the node.
And we can also make cosmetic changes.
Okay. Um. Uh. w- w- w-
Wait, so in a linked list, we have like all the nodes, the nodes all point to each other and then the last node points to the first node, right? Sorry, I think I missed the explanation. Is that right?
I don't think the last node points to the first one. I think it's just like the first one points to second, second to third.
Yeah. All of them point to each other. I didn't answer because wasn't sure about that second comment.
Okay.
I mean, I think you could do that, but I don't think that like we would have to in this case.
Yep. Okay.
Okay, so what exactly should I be doing?
Like if you scroll to the top of this one, then like I guess like from line 9 to like line 20, I guess. You can sort of like just change like copy that and then wherever it says like stack int, you can make it like list.
So wherever it says, so what, change stack int to just list?
Yeah, because like we're making the list with like a capital L.
No, right. Okay, then what? So now what?
I think now we can probably work in main to make two lists, I think. Because last time we set
Alright,
up a whole
so-
like, yeah, like a whole interface for people, like to like choose to pop and push and stuff. But if we're just gonna make a list, we don't need quite like we don't need both of the like the whole thing.
Yeah, I think like what Erica mentioned, we just need push, right? We don't need any of the other ones. Or I mean push and like two string.
Push and yeah, two string. Yeah, because we don't need to pop or know if it's empty.
Yeah, I think we could just go to main, but like just make sure everywhere it says stack int, it's like list.
Yeah,
instead.
yes. Yeah, so in front of all the functions and stuff.
Oh, okay, so I think that's all of them.
So then, since we don't need those other functions anyways, we can probably get rid of them, right?
Which ones?
Well, we only need to push into string, so, or at least comment them out in case there's like a use case later. But we
Yeah,
don't,
which
we
which
don't need
ones you want
it.
to comment out?
We don't need is empty. I don't think we need, yeah, I don't think we need is empty or pop.
Sorry, which lines?
Oh, pop, top, and is empty. Just go down. CC bool list pop.
Make sure to also comment them out in the class header.
Nice, Hannah.
Okay, so that's 33, right?
Yes, 33. And also Hannah mentioned in the
Oh.
class header, so 28. Oh,
Car, you can do like slash and then star and it'll comment out a bunch of
right.
lines. Yeah, it might be a little bit.
then yes, then star slash where like you unend it. So yeah, yeah, because we need the line above that one.
I think the star goes inside.
sorry,
Yeah,
yeah,
I always have such trouble with that.
I'm still waking
It's
up.
really confusing.
Okay, and then what else needs to be commented out?
The 28. Line 28. Because that's in the header. Or that's the header for pop. So if we comment out the function, we need to comment out of the header.
Oh, you can just comment out that one line. You don't need to comment out multiple lines.
Yeah,
Just like
just-
the declaration in the header.
You can comment out 22 as well. And probably 26 because I don't see us. Maybe, yeah. And then we keep going in the actual list of functions and commenting out like the block comments of the ones that we just commented out. So yeah, so we need push. We need push. We need the deconstructor. We need to string. The convert to TF was nice. Is that it? Cool. So then in the while, we can either get rid of or comment out the parts that have you type in the pop top and it is empty. So no, we need that one, I think. So the if blocks. So we need to be able to push. We need to put things in.
I think we can comment the entire thing, right? Because like we're supposed to,
Oh, yeah,
If
like a
we're,
whole
like-
new thing.
if we're just like putting in random numbers, we could just use like a 4 or like I don't know, maybe like
Oh, yeah,
I
that's
guess
true.
the one thing we need is like the size of the list.
There. Yeah, okay. You right in order.
Maybe yeah, maybe you can just ask the person like how long the list should be and then create like 2 lists of that one.
Okay, yeah, so we're scrapping this because we can do that ourselves, or like commenting it out if you want to refer to it. If you want, Karthik.
Okay, so what comment you got, 77 to 95 or what? Just outright deleting it.
Yeah. I guess that's what you want because we're gonna make a new thing anyways. But
Okay.
so then yeah, the Murata's idea was really good. Where like we can ask the person, how long of the string they want.
Okay, so what, see out how long do you want the string or what?
Yeah. Do we want to loop that? That's not
Wait,
what-
sorry. Why are we asking how long we want the string to be?
I don't know. I just like we need the length of the list, right? So I'm not sure like where we would get that. Like
I think like you're supposed to be able to like, aren't you supposed to just like add stuff to the list? So you just like push it to the list.
oh, okay, so like we don't need like an ending, like the full size. Then I guess like yeah, okay, yeah. Then I guess we could just like choose how many like
Because I think we're just implementing like the data structure. So like we just want someone to be able to like take this code and be able to like just make a list of any size without like, yeah. So like just
okay.
push stuff.
Yeah, I think did the prof mention like it has to be like 10 numbers or something for now?
Oh,
I
Like
I
think
don't know.
we have to fill it in with random numbers, right? Like I was like didn't know I don't remember how many there were supposed to be.
I think he said 10.
Okay, then yeah, then I don't think we need this. Then we can just do the 4, I guess.
Okay, so what do you want in here then?
I guess we could do like a for loop from going like from 0 to 10, just like iterate 10 times, and then like inside it'll put a random number as into the list.
So what for Um, Wait, so what do you, just, what do you want me to type?
So we do like for size T I equals 0. I like size T is the size T I. Like a space,
Space.
like size T is the data type, and then
Wait,
Yeah.
which one?
so like
Size,
size. Oh yeah, sorry, you can go.
so size T under, yeah, size T space I, because I is the variable. Equals 0.
Wait, so size underscore T space I.
Mhm,
Okay.
equals 0. Semicolons. Yeah. Like we're still in the loop. So yeah, so after the 0, you put in the semicolon. And then I is less than I is less than 10. Semicolon. And then I plus plus. And then the curly brace outside of the yeah, like no, you're good here. I plus plus, and then like the parentheses, then outside the curly brace to start our loop.
Wait, so you want curly brace outside the?
Like the
this-
yes. No, that's a tilde. Because I'm guessing it's not gonna be one line. Um, that's a tilde, like the one that the
Oh,
shift square
oh.
bracket. Yeah.
Okay.
Are we having like so it's just generating a random list of 10 things, or are we like making like putting 10 things into this?
I think it's just like random list of 10 numbers, except the numbers have to be in ascending order, like one greater than first, second greater than the first.
Oh, okay, great. So you can probably make like a number variable to put rands on. So int or size t. So size t. So size underscore t space.
So line 79 size underscore T space.
Yes.
Okay.
Number num semicolon. And then we can, yeah, scenario variable. So we could do like num equals rand. Something.
So
Yeah, so yeah, size underscore t num equals rand parentheses. Maybe. Also, feel free to chime in, guys. I'm
So let's say that one more time. So 79 size T space num.
equals rand parentheses.
Yeah, I guess we could like do, well, I mean, in like line 74, we can change like my stack to my list, and then like in line 74.
So 74. Say that one more time.
Just like change like my underscore stack to my underscore list, because it's a list now. And then like make a new line after line 79. And then you could like my list dot push num.
Say that one more time. My list. What was that?
Dot push.
Dot push.
And then parentheses and inside num. And then semicolon.
So could we run this? It should work.
All right. Well, let's see how many errors we get. Oh,
I think I need to call the two string because the main
hey, no errors.
Okay. Yes. Oh, okay. So yeah, on line 81. Yeah. So my underscore list dot to string. A TO string. Two parentheses. Did we? Does to string have a parameter? When we made it?
No, I don't think so.
Yeah. Okay, cool. So that should do it.
Or do you think maybe we should like print it outside the for? Because then if it's inside like every single, it'll print like 10 times.
Oh yeah. No, yeah, you're right. Sorry, I'm still trying to like not like thinking slowly with pointers. Yeah.
So I guess like Karthik, you could just like line 81, put it on line 83.
Take it out of the
Like
for
take it out of the for.
Oh,
And you need like a semicolon at the end.
And now try to run. Yeah, because in that way we're making the random numbers, pushing it 10 times, and then printing the list object at the end, right? Okay, cool. All right, let's try to run it.
Oh, I think we might need to see out because list to string doesn't print anything, it just returns. So we might have to do see out and then what that returns.
Oh yeah, you're right.
So like 83 in the beginning. It's like just do the see out. So
So now we have to make sure that they're like in increasing order, right?
yeah.
So let's get back in the code, Karthik.
Oh, great.
But it works. So maybe in the size, so maybe in the size t space num, we could, because we could probably put like a second variable and then just have it increase, right? Like the way that happened in quest 6. Okay, cool. So on like another line,
So what, 80?
yeah.
Okay.
We can probably make another size t. Wait, no. Wait, no, above that one, above 79. Num2 equals 0, semicolon, and then we can in size t num it could be equals rand. No, so on line 81, we could add num2 to it. So it could be no. So keep that as num, and then after the equal sign, we can have num2 plus rand. And then plus rand, and then after the push, and then after the mylist.push, we could have num2 equals num. Right, something like that.
I think that's correct. Only thing is, should when we're declaring num2 or like initializing it, should it
Should
be inside the for? Because because it's gonna overwrite, right?
Yeah, it is. You totally right about that. Yeah, so line 79 should be outside of the for. So like on what is that? Yeah. Wait, whoa.
Oh, wait.
Yeah, wait. Yeah, you can just cut it to outside to above the for. And then the semicolon. At the end of the no. Delete that semicolon so where you are at, yeah. So that should increase the number each time. Just press enter to exit the console. It's not letting you run it.
No.
Okay. Or maybe we, instead of size T, we can make them all ints. Let's do that. Yeah, I don't know.
Yeah, I think the only thing like maybe just the nums need to be not size T.
Yeah, let's change them all to, let's change those to ints. That's what I was, yep, I saw that.
Okay, so change which ones to what now?
80, instead of size T, make it int, and 77 int. Yep. Oh yeah, because we had. Okay. Yeah, that should be fine. Or not.
Wait, could you go back to the code for a sec? Do we need to modulo by something? Like, I don't think, like, usually we do that. Like, I don't think, like, we need to. Like, usually it's just to make it so it's within, like, a certain number. But, like, would that help if we, like, did modulo something?
Oh, God.
Maybe, or like, guys, I don't know why that's happening. Is it because we have size T in the 4 and the other ones are num and there's like size T num? Is that possibly why random negatives?
I don't know. I mean, I wouldn't see why, because the size T, like, we're not using
Yeah,
I
it's not
anywhere, right?
Yeah, yeah, it's not actually like interacting.
Is it? It shouldn't be like if num2 starts with 0 or 1, it doesn't matter, right? Like,
It shouldn't, no. Oh yeah, it's not gonna, yeah, we need to have it.
Yeah.
The professor did mention possibly needing sentinels.
Hey, I heard someone mention professor. Hey, no, you don't need sentinels for this, I think.
Okay.
You just have a linked list, 2 linked lists is fine.
And the 2 linked lists should be 2 linked lists of 10 random numbers that are increasing.
Yeah, that's all.
Alrighty. Anyone have any idea why that's happening? Is it something in like the 2 string?
Oh wait, what's the issue again?
So we're having, so we're trying to make the random list of numbers that increase, but there's negative numbers that are thrown in there. If we just throw an absolute value over it, it might fix it, like a band-aid maybe. So Karthik, run it. Yeah, so they're not, because they have the negative values, they're not like,
That's so weird.
yeah, right?
Um,
I'm trying to look up stuff online and it's like, we can turn it into content, but I feel like that's,
Yeah, I just tried like doing like the same thing, except instead of like just like printing out the numbers instead of like doing the whole linked list. And I think it's like the same. There's like negatives in there too, so I'm not sure why.
there's an absolute value function. I think it's in the conversion. Yeah, I think it's like on the converting to string part that it's.
I did a mod 10 and it worked magically. I'm not sure why, but it did.
it might be like because int like can only store a certain amount, and maybe rand can like go really high. So then it's like defaulting back into the max min of the
We did
int.
that, but we started with size t and that's what happened. So we changed it to int thinking it would help.
Oh,
Yeah.
oh,
Yeah,
we should do the absolute value.
Agreed. Let's see.
Or just, yeah, I guess I could try the absolute value, or else maybe just the modulo, just so it's easier since the numbers aren't like really long to count.
Yeah.
Wait. So
So like on line 80, like if after the rand, if you put like the percent symbol 10, like after the parentheses of the rand also. Yeah, and then delete the one that's right. So like rand parentheses. Yeah, there you go. And now like if you ran it, well, like okay.
so mission accomplished.
Yes. Yeah, yeah, that's that. I like that. It's limited to make them tiny.
Yeah.
So yeah, they were, I guess, too big, and that's why that was happening.
I don't know, maybe. I'm not sure.
I kind of
Well,
want to ask
it
why
works.
Yeah.
it does work.
Or is this supposed to be ascending or descending? Because like I tried this on my own, like just printing out the numbers, and it's like going from 3 to 47. So maybe it's like because like the push, I think we might have to change because this is stack. So maybe like the way it's printing or like pushing is different. But like I think it's like does that make sense? I don't know.
Yeah, no, you're right. I think it's because it's pushing, right? And each time it pushes up like to the top.
Mm-hmm.
And so
Instead
we're
of like
printing.
making it this way, yeah.
Yeah, and so we're
So
like
what,
printing the
pull?
whole thing.
So what do you want to change then?
Um,
um, mm, because we want it, should we change it so it's backwards? But then like because the stack
I don't
is
know.
fine. It's just the way
I think this is good enough.
Should we ask?
Yeah.
Yeah.
I think.
Question, Professor.
Yeah, okay, all right. Sounds like you guys are done.
Oh, we had a quick question. We're not.
Yeah,
just
sure.
One last thing. But so since we're pushing 10 random increasing numbers to stack as they push, it puts it onto the top. So when we print it, the printed list goes from big to small. Do you want the printed list to be
Oh, I
flipped?
see.
Do you-
Yeah. It doesn't matter, but I think it'll be nicer if you do it the right way. So I think what you're doing is you're doing the
Sure.
same kind of insert as you're doing in a stack, meaning that every new node you create is getting pushed onto the front, okay? So that is the bit that you have to solve, and it's very easy. All you need to do is just, you got a new node, you got to push it onto the end, and then the next node that comes in is going to get pushed onto the end too. So the thing you can do is just remember what the last node is. So don't let go of the last node. So after you push a new node onto it, so in fact, don't call it push, because push is like stack, and it kind of seems to indicate that it's going on the front. Call it insert, okay? Or append, call it append instead of push. So append always goes to the end, right? So all you have to do is get a new node, push it on the end. Now this is my current, I hold on to the inserted node. So the next node that comes in gets becomes the next of this one. The next node that comes in becomes the next of that one. And the last node you push will need to have a null for its next. That's all. Okay. Do you guys want to do it, or do you want me to walk you through this? I think you should do it. Okay. Should be pretty straightforward. Now, it's okay if Karthik wants to hand over to Elijah, that is fine. But I think Karthik, you will actually find it useful, unless Elijah really wants to do it. Elijah, do you want to do the adjustment to the code, or can Karthik continue?
Nah, he got it.
Awesome. Okay. All right, Karthik, this is what you need to do. First of all, call the method append instead of push, because it's kind of confusing otherwise, I think. And then all you have to do is just keep pushing to the end, not to the beginning. That's all. Okay. And your toString seems to be working properly. So. And also you got to indent your code. Indent your code properly. The for loop statement should be inside. And you need to break your code with declarations and then a blank line, because it's the next paragraph for the logic. All these things, also beautify your code a little bit. And I think it's, it seems to be ready to go. So do that. We have time. Okay, because all we need to do today is really just go ahead and try and merge those. Okay, and in fact, even for merging, I will tell you. I'll tell you how to do the merging. And then maybe you guys will do the merging. Okay, you guys will do the merging. And the reason being that I think I may not have to walk you through this. Okay, I think it may be easier if you just do it may be better if you do it. Right. So here you go. All right. So it's up to you guys. You guys go ahead and do this, and call me again. All right. I'll be here. And yeah, indent the code and lay it out clearly. It'll be easier to debug.
Okay, so in that case.
Okay, so how should I sort the spaghetti out?
Would we need
What,
like a tail?
How do I make it look nice?
Oh, for that, I guess like 80 to 82 like indent. I think we can like keep the like parentheses with the 4 because it's like one thing.
Also, what's that? What's line 76? Probably delete that. What is that?
So what, just delete
No, just the line. Wait, like, because it's a hyperlink, right?
Yeah, I think it used to be a comment. I don't know what happened.
So we need to go in and change the way it pushes, right?
Yes.
So we have to go up to the list, the push, that push function above name. To string TDF push. So below, go down. Keep going down. There. Yeah, so we need to change that function, that 43 to 47. We need to modify it.
If we need to like remember the end, would we need like we have our top node, would we need like our last node, like pointer in the class?
Oh,
Because like right now, like
yeah.
it's like we have our top node that's set to null, and then we create like a new node, and then we set like top node to that node every
Right.
time. But then like if we have top node just like there, but then we need like a last node, because then we can set last node equal.
Yeah.
That would,
No, you're right.
like in theory, like I'm not sure how we would actually do that, but like in theory, that's what we need.
Well, can we just go up to the top of the class and then just add like, or
Yeah,
yeah, in like private, like
Mhm.
make a last node. So if we go up to list, like at the kind of like the top of your code. See, yeah. So in private, I think we can make a new node. So line 17. We can make node space star last underscore node. And then in public, we would just put it in that return value too after the semicolon, right? Like,
Yeah, I think you can like after the null pointer semi, you can just do the same
Yeah,
thing
that's
again.
awesome. Yeah, so after the on line 20, after the null pointer semicolon space, we could do last underscore node equals null pointer. Yeah, and so then we should we just get rid of top node, or should we, or just, or we can just, yeah, we can just add.
Yeah, I'm like I don't like I have to think about it. Like I'm not sure. Like I don't know. Like yeah, maybe I'm not sure. Like walk through it and like see what points to what, and then maybe we can get rid of it if we're not actually using it anywhere.
Yeah, I feel the same way about deleting code, to be honest. I just comment everything out and I'm like, oh, okay, you're actually useless. Like we can delete you now. Okay, so yeah, and we did that for the list. So
Could you go down back to the push
yeah, so yeah, we do, yep, go to push.
or like the function?
So like the line 40 something. Yeah. So node star node underscore p equals new node, yes. Node underscore p data, and yes. Node underscore p next equals last node. So
Yeah.
Wait, so line, which line?
47 instead of top
47.
node, it should be last node.
Well, is that like the same?
Same thing, yeah, no, never mind. JK Carter.
So like we create a new node and we set that data to n, and that next should be set to last node, but then last
It
node.
feels like we're doing the same thing though, right? 'Cause
Yeah.
we're,
But at some point, like the prof mentioned, the next has to be null, right?
yes, the last one. Or
What if we set the next to null and do like last node equals node p?
Wait, what?
So like 47, the next equals null. And
Mm.
then 48, like last node equals node P. So like that node that we just created, the next is null, but the last node is still like, so like remembering that as like the last node.
With that, but we're never pointing back to the last node, are we?
But
Sorry,
like
I'm confused.
if we just like, oh, I mean, okay.
No, I think don't. You
No,
know,
yeah,
you
no,
know more,
yeah.
you know more about pointers than I do at this point.
No,
But
no. I'm just trying to think about it, yeah. Oh, wait, what if like before everything, we have like last node, like the last
Okay.
node next is the new node.
Oh,
And then at the end, we change last node to like the new node that we just created. Does that make sense?
I think, yeah, I think that
So like after 45, you do like last node equals node P. And then you could do next node P next is like null. And then last node equals
yeah, okay,
node
yeah, that, yeah, something like that. I feel like that would work. Because
We can try.
that would be that would make the last node equal null because the next is null. So it kind of falls into what he said. Okay, so node P equals node. So that's something we would define in like the class, like in the private.
I feel like what do you mean? Like,
Wait, okay, never mind. You're right.
could we do
Wait, no,
that?
because like in the list, because we made last node null pointer, so we would make last node the next node.
Well, like, I guess like, cause like that's like when we're starting out, like it's everything's empty, but like in the push, would we do that?
Oh, yeah. Okay, yes. Never mind. Go back to the 40s, Carter.
I don't know.
Back to the
it's
40s. Okay.
just an idea.
I think it's a really good idea. So on line 47, we would make node P, like after the equal sign, it would be null pointer.
Yeah, I think so. And then at some point, and then I guess like after 45, like make a new line. And then what if we did like a last node equals node, last node next. So like
Yeah.
arrow next.
Wait, what?
You
Dash.
see how like we
greater-
have the dash and the caret, like,
Oh,
yeah.
Next. Equals last node.
let's say that again.
Equals last underscore node. Semicolon.
And then we can probably maybe comment out line 49 for now.
49 comment out. All right.
Okay, that feels, yeah, that feels like it. This feels promising. Let's try it, yeah.
Oh, I think we might have to look at our two string.
Yeah, 2-string.
Oh, that's where we use top node.
Oh, okay, yeah, there we go. So wait, okay. So the reason we use top node is
Would
to
we,
point.
would we need a sentinel in that case? Like a place to start?
Yeah. Well,
Or,
could
oh, that's right, go ahead.
no, you go ahead. I was just gonna say like, oh, can like it should be able to work with last node, but like you probably have an actual idea. So go for it.
No. I was just like, yeah, I mean, we could try last node. I don't, yeah. If we do last node, the only thing, like if we start at last node, would the next just be null? Because like it's already the end,
Yeah.
right?
Yeah, no, yeah. I think that's right.
I was just gonna say, like in our push, like if the top node is null, means like it's the first one we're pushing in, top
Mhm.
node equals also that new node. And then after that, we never reassign it. Does that make sense?
Wait, sorry. So yeah, make the top node null and then the last
Just-
node.
So like when we first create it, top node is null. So
Yeah.
the first time we append, if
Mhm.
top node is null, then top node would also equal that node. But then like the second time we append, top node is not null, so we don't do anything to it. So that way, like it keeps top node what it was like the first time,
Oh, so you could still use it kind of like as a
as like
Like
the first node.
right, like
but-
as a placement.
Yeah.
Okay, yeah. So we didn't delete any of the top nodes, so maybe go back to in the 40s and uncomment line 49.
And then I guess just. Oh, okay. Wait, why is it not printing anything?
Yeah, that's
Oh, maybe it's like oh wait, if you could. And we just added last node, like it shouldn't change how it was working, right?
maybe it's the way we're pointing to null and it's not really
Oh, because we changed it how the top. Okay, maybe
Yeah.
like. Okay, maybe like. Partha, could you go back to the 40s? If like after 48, line 48, if you did an if saying like, if top node equals null pointer. And then like colon. Or like, sorry, you
Okay.
you don't need anything, sorry. And then just like indent 50,
Then indent the what?
indent line 50. Like, would that work?
That would let you know.
Oh, you need, I think, parentheses around the entire thing.
Oh, in the if state, yeah. No, so like in the on line 49, the top node equals null pointer should be in parentheses.
Never mind.
Do you have any ideas, Hannah?
No, I'm a little lost.
It's okay, we are too.
Do you guys want me to take a look?
Yes, please.
Yeah, we're kind of
Hey, okay, great, okay, let's take a look. This is nice. Right here. All right, so what's going on? What is the problem? What's going on? What do you think? Where do you think you're stuck?
Oh, we're confused. So we
Let's take a look at the code.
Right.
Let's go to your main.
so here, well, what we're trying to implement, it was the last node so that we can, instead of calling and moving it to the top node, the next would be a null and we would have like go to the last node instead of like the top node. Like
I see. You're not making the nodes in main. You're giving the node. So where is your list? So can you scroll up a bit more?
It's in the
Where you
40s.
make the list?
Go back to 40s.
All right.
We're trying to
push.
push the right.
Okay. So. All right. So it's not append. It is push. Okay. So you're calling it push. Okay. So you're making a new node, and the last node arrow next equals Well, when you make a new node, why are you setting the last node next to the last node? The last node should now be the new node that you created, isn't it?
Yeah, I think it was supposed to be that.
All right, so let's change it. So what you need to do is cut line 46. Cut line 46. Don't delete it. Cut it. Cut it. Take cut it. All right. Now node p data and node p arrow next is null pointer. Okay. Top node. You don't need to mess with the top node, so you can get rid of 48. You can get rid of 48, and then what is the current last node? So you have the current last node. So you can say, yeah. So all you hit enter. Hit enter. You say last node arrow next equals node p. In fact, if you arrow next. No, last node arrow next equals node p. No, arrow next.
Write the word.
Arrow
Write the word next. Write the word next after the arrow.
Oh, yeah. Okay. Arrow and no space before the next. Yeah. That's nicer. Okay. Equals node p. Yeah. And then the only semicolon. Now, what is the last node now? After you did this, what is the last node? After you did this, here's your last node. Okay, just try to visualize this, because when you work it out on paper, you'll see exactly what's going on. But here's my linked list, lots of nodes. This is the last node. Okay, I manufactured a brand new node. I stuck it onto the end now. Now, where is my last node? What is my last node now? This was the last node. Okay, this was the last node. I made a brand new node and stuck it on the end now. Right? So which is the last node now?
Should be the second one.
Yeah, the new node you created, because the node that was previously last is not last anymore. Yes. Because something else became the last node now. Yes or no? Everybody needs to be on the same page here. Okay. So all you need to do is just say last node equals on the next line, you just say last node equals new node. Last node equals node p. All right. So I know it's just a couple of lines, and it looks kind of strange. Oh, next line, hit enter. And you say last node equals node p. Now, can you understand what's going on here? That's the important part. Okay. So we have A, B, C, D, E. Okay. Those are the nodes. A is the first node. E is the last node. Yes or no? Okay. Now, X comes along. A node X comes along. Where are you going to stick X?
We already have like these 5 nodes.
Yeah, we already have A, B, C, D, E. That's the link, right? A points to D, B points to C, and then E points to null. Okay, E is the last node.
Okay.
Now
so
X comes along.
we put it in A.
No, it's append. It's append.
Oh, appending, right? So we have
Yeah. Right. Okay. So it goes after E. Now, what is the last node now after you change the list?
X.
Yes, exactly. Thank you. All right. So that's what you do. On the next line, you say last node is now X. Last node is now the new node that you just created. Does that make sense? Okay. It's very simple. It may take a few seconds to get your head around it, because especially since you're doing something like A equals B, now B equals A. On the next line, it looks like that, because you'll be doing a last node assignment. And then, so it looks confusing, but it's not confusing, because you're just taking that pointer in there. And it's all a question of getting used to the pointers, the level of indirection. Okay. And it's just exposure. And that is why, Karthik, so people like Karthik, who are just here to get a smattering of what's going on. All right. So I want to learn about computer science at a high level. Okay. So it'll be harder for you to get to the bottom of this, mainly because this thing here, it's like a few lines. It'll work, but you need to ponder it for a little while until you actually get solid intuition about why it works. So I just described it. Okay, A, B, C, D, E. New node comes along. That now becomes the last node. So now the last node has got to be X, not E anymore. So you're just changing it. That's all. Is everybody so far okay so far? Okay, great. So that's your last node. I can get rid of the blank line after that. Okay, and while we're at it, if it's not too much of an effort, change push to append so that it's not confusing. So I saw that you know, Erica got confused now also.
sorry.
when she-
Yeah, I did.
Call,
We did-
call
yeah,
it
we-
append. Call it append.
Mhm.
Yeah. No, APP, two P's. APPEND. All right. So anywhere else that you're calling push, where are you calling push? And you also need to adjust the signature in the class, in the class def, where you say push, you got to say it's not push, it's called append. It should be below. It should be below that.
Yeah.
There you go. Push.
30.
Okay, and then you have one at the very end, I think, where you call push. In your main, I think you should have a push, right?
Yes. So in the for loop,
There you go. Change that to append.
83.
Okay, great. Now let me take a look at main. Okay. I see. You're just appending the number. Number 2 plus %10. Good. All right. And you're appending it. And then num2 equals num. Why are you doing num? Oh, I see. Because you're going to be incrementing it the next time. So what you want to do? Oh, why is it working? It's. Oh, I see. Num2 equals 1. Oh, you're calling it num2. I see. In fact, instead of calling it num2, let's just make a change in name. Call it last num. Call it last num. Instead of num2, just in main, just change line 78 to say last num instead of num2. Because num2 has less meaning for programmers than last num. Yeah. Change on line 78, change num2 to last num. Line 78. Call it last underscore num. And then in the for loop also.
Last
for
underscore
loop,
what?
num. NUM. Yeah, and in the for loop also change num2 to last num.
So 84 would be last underscore num equals num.
Yeah, and also 82. 82 also.
And then yeah, int num equals last num plus round. On 82.
No, 82, line 82.
So that num2 would be a last underscore num.
Wait, say that again.
Change
Say,
Line
wait,
80
so change 82 to last num equals num2, or
change,
int
yeah.
num equals last num?
Yes.
Great. Okay. So my list to string. Okay. So and print it now. Oh, it still doesn't print anything. Okay. So now we can take a look. All right. Where is your toString? And by the way, you need an end line after after your toString, right? So after your toString on line 87, you need to put an end line, ENDL at the end. At the end. No. After mylist.toString, before the semicolon, say left shift and L. On the same line, just say left shift and L.
Two less than
No,
sign.
two less than signs. Yeah, two less than signs, and then end L.
Yeah, I think since we were confused with like making the next, we were still changing toString too, I think.
Sorry.
Yeah, I think in the 50s is our toString. We didn't change it, I think.
Oh, I see. My list of toString. All right, let's go to the line 50 or something where Erica is saying we have this. No, toString. Where's your toString? Yeah, 61, line 61. Go to line 61. Yeah, there you go. No, line 61. That's into a list. Okay. Top node. Oh, I see you're calling it top node instead of first node. Well, is your top node correct, by the way? You know, how do you know your top node is correct? Are you changing your top node anywhere? Where is your top node?
I
Oh,
think
by
we
the
just
way,
deleted it.
I think it's
but
just
you have you know, you're assigning top node to things and all. So
I
how
think
could
it's
you
like null in the constructor. We set it equal to null and we never change it anywhere again.
oh, all right, no, that explains it. Okay, so because your toString is starting from top node, yeah. So if it is null, it's not going to print anything. Yes or no? Right. So it's very simple. Just go to your constructor. Go to your constructor. It should be null. It should be null in the constructor. Now, when you push. Oh, I see. I see. So yeah. All right. Go to your push method. Go to your push method.
So for
Append. Where do you have append? Where do you? I think where do you have append?
like 40s.
Yeah. All right. So we're going to change this slightly. All right. But before we change it slightly,
Is it a
can you change? I will leave it as top node. I was thinking we should change the, you know, we have last node, we should also have first node, but we'll just call it top node. You
So
know,
it's
we
good
don't have
to, it was good to keep that then. It was good to keep that top node then as like a placeholder.
Yeah, I think it is good because you have a separate class, you need to get to the first node, right? So it's good to keep the top node. However, when you try to push something on, all you're going to do is check if the last node is null. If the last node is null, then your new node is the last node. If the last node is not null, then it goes on to the end, and then that becomes the last node. Yeah. So all you have to do here is in your append after 45, hit enter after line 45. Hit enter after 45. One more. Okay. Now you're going to say if last node is not equal to null. Yeah, not equal to is vertical bar equals, and then it needs to be within parentheses. The condition needs to be within parentheses, not vertical bar, exclamation mark. Sorry. Yeah.
Not equal to what?
Null pointer, nullptr. Right, and then in parentheses, the condition should be within parentheses. No, the condition, the if condition should be within parentheses. Yeah, exactly. Yeah. So now cut lines 48 and 49 and put them above the if statement. Blank line, blank. Oh, no, blank line after that, because declarations need to be separated from the body of the code. No, blank line before, after the declarations. Yeah, all right, good. Node p data. All right. Now, if last node is not equal to null pointer, then you say last node arrow next equals node p. Else last node hang on. Yeah, else last node equals node p. That's all you have to do, right? So if, yeah, in fact, you can do this using ternary also, and I'll show you after this, okay? No, you don't need if there. All right, so you just type in this for line 51. Yeah, line 51, get rid of the if, right? Indent in, last node arrow next. If last node is not equal to null pointer, then last node's next equals the new node you've created. If the last node was a null pointer, then the last node is just the new node that you created. Yes or no? We have to agree on the English description first before you code it into C++. Yes? All I'm saying there is just try and think about it as just in language, okay? Just in human language. I just made a new node, okay? Now, if the last node did not exist, if the last node was already a null pointer, then I don't have anything to stick it on. So this new node that I created is both the first node and the last node. Yes, because the list was empty. So you say, if it was a null pointer, then this is the last node. If it was not the null pointer, then there was already a last node. Then I'm going to change the last node to be this new last node. Yes. So that's what you're doing there. So so you say else. So yeah, you say else there, and then hit enter. Hit enter. Right, and indent in. Right now, go to the end of that line and put hit enter. One more, and then go back. Let's start a comment. No, not all the way. Just indent in and start a comment. The same, the 4-line if statement can be condensed into a single ternary statement below. Can, not can't, right? Can be condensed. Yeah, into a 1-line ternary statement below. Ternary, T-E-R-N-A-R-Y. T-E-R-N-A-R-Y. N-A-R-Y. Statement below. Yeah, so that's what we're going to do. And no, not below, right? We want to just below, right? Okay, right, hit enter. And all you have to do here is simply say last node equals, again, right? Pay special attention to this line, this entire function. Maybe you guys have to get together and discuss this and try to understand this properly, even though it's like 10 lines. This is like, there's a lot of really, really subtle nuances going on in here. It's very important for you to draw things out on a piece of paper with lines, connecting circles or whatever it is. And just get, you know, once you have a pictorial representation in your head, it is very hard to forget, okay? If you have verbs and words are easy to forget. But pictures, our minds will basically stick, you know, it's harder to forget pictures. I don't know, right? I'm just spouting on the top of my head, you know. Erica's the one with the neuro background and all. So, right? So, but getting it into pictures, yeah, there, you know, the ancient people said that, right? A picture is worth 1,000 words. Isn't that right? My grandfather used to say that all the time. Right? A picture is worth 1,000 words. Oh, actually, no, he used to say, writing once is equal to reading twice. That's what he used to say, right? So, you know, when I was young and I was trying to, in my school, there's something called by heart, okay? By heart meaning you get given a poem, you have to memorize a poem and then speak the poem without looking at anything. So it's called memorizing the poem. And I used to memorize it by reading it loudly, repeatedly, okay? Reading it. And my grandfather used to walk into the room sometimes, say, "What are you doing?" I said, "I'm trying to memorize this poem." And he said, no, don't, that's not the right way. Writing once is equal to reading twice, okay? Like that, you know, making a picture is equal to 1,000 of these words, okay? So make a picture. Last, question number 9. You will not pass question number 9 if you don't make pictures on paper, okay? The only way to pass question number 9 is by making pictures on paper and understanding exactly what goes on, okay? So last node equals, and then within parentheses, you're going to say, last node double equals null pointer question mark. Oh, all right. Unfortunately, oh, bummer. Okay, you need the if statement. I'm so sorry. We can't do a ternary here. Because in one place you're assigning to last node, in the other place you're assigning to last node arrow next. So you can't do a ternary here. Just delete lines 55 to 56. That's enough. You know what you have there is probably the best way to do it. Yeah. All right. So you can get rid of that. I'm sorry. Okay. So that is it. Now, I think if you run it now. Yeah, you have a blank line there too. You can get rid. Oh, wait a sec. Get rid of it. Now, why is it still printing a null? Or where's your top node? Oh yeah. Okay. All right. So all right. So yeah. Go to your append method again. It's just one more thing we need to do. Right? Yeah. That's what we started to do, and I forgot. As we after the else. Yeah. Curly brace. Curly brace after the else. Yeah, all right. Now after line 53, hit enter. Now you can say first node, or what is it you call it? Top node. Top node equals node P. Okay, meaning that, you know, in the beginning there was nothing in there, and a new node was pushed. Now there's both a first node and a last node. Yes or no? First there was an empty list. So there was both first and last node were pointing null pointer because the list was empty. Now a node came along and that got pushed. That's the first node, but also it's the last node. Yes or no? The first node that got pushed is also the first node and the last node. Yes.
Well, yeah, if it's the only node.
Yes, if it's the only node, right? So that means if last node was yeah, if the last node was a null pointer, that means it was the node you're going to push is the only node. So that should be the first node and the last node. So that's what you do there. Now you can close the curly brace after that, and I think if you run your program now, it'll work. Okay. So no, you have to close. You're very impatient, Karthik. Okay. All right. Okay. All right. So you gotta.
Two curly braces.
No. Close it on the next line. It's nicer. Okay. Close it on the next line. No. Take that curly brace and put it on the next line. All right. So and you're still getting a close, and then you got to close the function. You got to close the function too. One more enter.
Two curly braces.
Right. Yeah. All right, so I think if you run it now, you should see only 3 elements. No, only 2. No, maybe increase the size of that. Are there more numbers before the 3? No, increase the size of the black console, just the console. Oh, yeah, there are no numbers. So what's going on? Well, what happened to all the middle numbers? Maybe maybe I made a bug here. If last node is not equal to null pointer, then last node's next is the new node. Otherwise, the last node is the new node, and the top node is the node pointer. Okay, right, that should be the very first append, and after that you're not changing top node anywhere else, right? Just control F and search for command F and search for top node. I want to see where else top node is being used. Command F. No, top node. Yeah. How come you're using 10 places in here? No, don't replace with anything. So let's see where the first place you're using top node is, because I think it's probably changing in some other place. Where else? All right, so all right, let's scroll down slowly from here. Hey, by the way, there's a band. I can't. There's a band of something that's in the middle. I can't see. Yeah, what's going on? All right, so top node. Scroll down. So that's the top node. All right, no, not so much. Not so much. Okay, all right. All right, append will do that. I think it's doing the right thing. All right, and list node. Oh, wait. Oh, that's your toString. Oh no, why? Oh, destructor. Okay, destructor top node. Okay, and doing that. toString top node. P equals P arrow next. Yeah. All right. That all looks correct to me. Now let's and in your main. Let's scroll down a bit more to your main. I want to see. For 10 numbers, I plus last num plus 1. Yeah, and you are inserting 10 numbers into my list, and last num equals. All right, I can't see any errors in here. So let's here. Do you guys want to debug it with me? I'm happy to stick around and debug it as long as you guys want. Okay, it's not a big bug. Okay, it's a very small bug. Probably take us about 5 minutes to fix. But I'm wary of the time. It's about 10 o'clock. Okay, if you guys want to stick around, we'll probably fix it by 10 past 10 or something. Okay, are you guys okay? Raise your hand if you guys are okay with that. Okay, good. Let's fix it. All right. So main. All right. So here's what we're going to do. On line 90. Hit enter on line 90. Go to the end. Yeah. All right. There you go. Now you're going to say C out, left shift. And then within quotes, you say after inserting num. All right. After inserting space, and then outside of the quotes, you say left shift num. No, you need a space there because otherwise the num will run into inserting. Yeah, inserting num. Left shift again within quotes. The list equals, or within quotes you say the list is, and then slash end right there, slash end, or andl or slash end there. Left shift. Okay, and put a semicolon at the end. Now, if you run it, we'll see it happen 10 times, right? So 10 times, yeah. Insert the. You put a space before the. Yeah, put a space before the word the. There you go. Right. So after inserting 47, the list is 347. Why is it not going on to the next line? Why is it not I equals 0, I less than 10, I plus plus? It looks like the program is dying. Okay, it looks like the program is dying because it printed
after the second one.
And why didn't it print anything after 3? Why didn't it say after inserting 3? Yes. After inserting, it should have said after inserting 3, this is your list, and it should only have 3 in it. Why didn't it do that? It went straight to 47. So something is wacky somewhere else in the code. So 0. Let's go and look at your constructor. So I didn't take a look at that before. Sorry. Let me take a look at the constructor now. All the way. Yeah. All right. So no. Let's look at this class. Okay. Node data node star next. Okay, that's good. Node top. You got the top node and last node. Okay, that's good. And then your constructor. They're both set to null pointer. That's good too. A destructor we'll do later. And now further down a bit. Further down. Yeah. Further down. All right. So and append takes an integer. And then it's going to create a new node. Yeah. Creating a new node. Wait, yeah, there you go. Stop. Right, so it creates a new node, puts the data in the new node, and then because it's going on the end, that node has got to point to null pointer. That is correct. And now take the last node. If the last node is not a null pointer, then its next is going to be the new node that you created. Otherwise, the last node itself is a new node created. And the top node has also got to be a new node you created. Well, it is certainly perplexing for me because, in fact, the destructor code is not relevant. You're not calling the destructor right now. So the only thing I can think of is, yeah, let's go back to your main again, right? Maybe there's something here that is so obvious that I'm missing it too. So let's go to your main. Let's go to your main method. I is less than 10, I plus plus. I just not append. Put a C out right in the beginning of, after int num equals, yeah. After line 87, hit enter. And say C out, say inserting num, right? Inserting num, right? Within quotes, you say inserting and then space and then left shift num, left shift num, left shift endl after that. And then inserting should be corrected to inserting. Yeah. Okay, run it now. We want to see.
Yeah, we can see after it num because it's after it.
Oh yeah, you got to put it. Yeah, take 88. Yeah, that's right. Take 88 and move it after 89. Triple click on 88. No, triple click is easier. Delete. Right now, go on to the hit enter. In fact, you can go right to the beginning of 89 and yeah. Now you have to adjust the indentation. Okay, now run it now. Run it now. Okay, now increase the size of the console. Increase the size of the console. Okay, great. Inserting 3. After inserting 3, the list is. Oh, look. After inserting 3.
So it's our pen.
Yeah, put a space. Put a space. There you go. Yeah, run it. Let's increase the size of the right. Inserting 3. After inserting 3, the list is. It didn't print the list after inserting 3. So why didn't it print the list after inserting 3? Yes, that's the question. Why didn't it print the list after inserting 3? So wait. So which means it. Inserting num, last num.
So yeah, because none is, so that means that none is changing, but it's not appending every time.
Oh yeah. Can you take that line? You put line 90. Line 90 should go before 89. Okay, by the way, just take line 90 and go make it before 89, not after 89. Triple click on, triple click, delete. Triple click, delete. Triple click and cut. Now just up arrow. Don't change your mouse. Okay, just up arrow one time. Now paste. Okay, good. Right now, run it now. Right now, increase. Inserting 3. After inserting 3, the list is, and it didn't print anything. It should have printed a list with 3. Yes. So now that's what we want to get to the bottom of. So
we call toString outside. So is that why? Like we're calling the toString like after the 4. So if we call it like.
Oh, you don't have. After inserting. Oh yeah, we're not even printing. We're not printing the list. Yes, we're not printing the toString there. Okay, yeah. I'm so sorry. Thank you, Namrata. Okay, go to line 92. Go to the end of line 92. Hit enter. Yeah, now you got to say C out. Basically, that line 96. Copy line 96 and put it there. Yeah, my list.toString. There you go. All right. Yeah. Thank you, Namrata. Okay. Now let's increase. Okay. Now go to the top. Yeah. Scroll down. Scroll up a bit more. Oh, yeah. Okay. So we can see what's going on. All right. So the bug is very clear at this point. Okay. So after inserting 3, the list is correct. It's 3. But the next node that comes along, 9, is being inserted after 9. That is okay. But then the one after that, 16, overwrites the 9. It doesn't. It is overwriting the last node instead of going on to the end of the last node. It is overwriting the last node. So that is very nice. So that gives us a lot of information to find the bug. Okay. So why? So in our append method, we need to find out when a new node comes along, why is it overwriting the last node instead of going on to the end of the last node? Yeah. So let's go to the end. Go to your append method. Right, in your append method. No, append. No, I think it's further up.
Somewhere in the properties, yeah.
Right, node data. So yeah, this is the logic. Okay, this is the logic that has the bug in it. So you just have to figure it out. And so you created a new node. And then the last node is a new node, and the first node is also the new node. And the next one that comes along will be stuck onto the end of last node, not to the beginning of last node. And I mean, it's going to be. It's not going to replace last node. It's going to be stuck onto the end of last node. Arrow next equals node B. That's good. Else last node equals node B. You know what? I can't. This seems to. It seems to need a bit more debugging here. Hang on. So else last node equals node B. So let's put a cout statement after in the else part, inside the else part. Yeah. No, before the two assignments. Put a cout. By the way, we're using cout, which is a poor man's debugger, which you won't have to use if you're using VS Code or Xcode. You can actually debug in the code, and it's much easier. But, we're doing cout here because we can debug in here in online GDB, right? So you can say inserting and within quotes. You can say inserting within quotes. Karthik, are you spacing out or something? Yeah, you shouldn't space out, okay? You should be in listening mode, scanning mode, like Alexa. All right, okay. So so you say, yeah, what did you say there? Cout. You want to say, yeah, inserting. Yeah, space, and then outside you say num. Outside you say, yeah, n. Inserting n. Left shift n. No, inserting space, close quote. You got to remember. The last time you did that, you had that bug, right? You had to go back and put a space in there. Yeah, right. And then left shift. At the end of, or after. You say after. Node space. And then outside. You say outside. Say left shift. No, outside the code. Yeah, left shift. Last node arrow data. I
have a question. If this is in the else statement, isn't this when there is only one node? Because last node and top node both equal node P. Like, would this cout go on the other in the if statement?
Yes, we we need one there too. This is what will happen. Oh yeah. Yes, you're right. Thank you. Right. So what Erica just said. Just first of all, let's complete this line. Put an endl at the end. Right. Remove the space before the data. And put an endl. Yeah. And then left shift endl. You got to get in the habit. Okay. You're just lacking practice. Karthik, which means you got to be doing more of this. Right. That's all. Right now, triple click the line, and then cut it. Right now, go to your line 50, go to your line 50, go to line 50, space curly brace, space curly brace. Right now, hit enter. Now, paste what you have. Set up the indentation correctly. Right now, take that last node equals next. That has to go inside the curly brace. The next line, line 53, needs to go inside the curly brace. There you go. Right. Yeah. All right. So last node, arrow data. Oh, yeah. All right. Okay. Yeah. All right. There was I found the bug. Okay, I found the bug. We're not changing last node. So here, that's what in the if statement. Who pointed this out? Namrata or Erica? Erica, right? You pointed this out. In the if statement, you got a last node, and it's coming up here, right? But after inserting the last node, you haven't changed the last node to say this is now the new last node. We didn't do that. That's all. That was the bug. So in fact, we can simplify this a great deal by saying, all right. Yeah, okay. So this is the I just change that not equal to just double equals, right? Change that not equal to double equals, and you'll see what's going on. Okay, so change that on line 50, change that to double equals, right? Now cut line 51, cut line 51. Oh wait, yeah, right. If no, wait a second. Yeah, no, cut the next one also. Cut the next one also. Cut the next one also. Yeah, cut them both. And then if it is equal to null pointer is what you want to do the else. So you can get rid of the else, You know, delete lines 52 to delete lines 52. Yeah, those two lines. No, just the line 52 and 53 only. Only 50. No, not all of it. Put it back. Just 52 and 53. Right now, push. Yeah, great. Okay, if it is equal to null pointer, that's what you're going to do. And outside, no, wait. After 53, hit enter after 53. Hit enter after 53. Here, else. You want to do else. Last node arrow next equals node B. No. Enter. Else enter. Else and then enter. You say last node arrow next equals node P. Arrow next equals node B. This is the third time. Right, arrow next, you need next there, right? Equals node P, semicolon at the end. Indented in. It needs to be 4 spaces in. Now cut line 51. Cut line 51. Cut it. Did you cut it? Right now, take that and put it on line 50. Go to line 55. Hit enter. Enter one more time. Right, paste it here. All right, now back indented. No, back. It doesn't belong to the if statement, right? In fact, what you can do is line 50. Take off the curly brace. Curly brace. The if statement doesn't require curly braces, right? Because it's only once. Yeah, blank line. Get rid of the blank line also. Right. So let me run through this logic. Last node equals null pointer. Then top node equals node P. Yeah. Okay. Why do we have? Yeah. If it's top node equals node P because it wasn't there. Else, you're going to say last node next equals null pointer, and then you say last node is the null. All right. So this should work. Okay. Now let's run it. Make sure it works. And then after that, you can figure out the work through the logic. Is everything okay now? Okay, good. Right. So now go to your main method. Now that we've debugged it, right? Go to your main method, and then get rid of the cout after inserting and all that. That can go. Get rid of all the couts you have. There you go. Yeah, they can go. That can go. And then the first one, inserting the online 89.
Wait, go back. I think you deleted something. Oh no, there is couts. Okay, never mind. Sorry, I thought it was like a line. Very good.
So you can get rid of those 2 lines also. Now, what we want to do is make that, no, you don't need to run it. So so list line 83, line 82, right? List space my list 1, comma my list 2, right? Say comma my list 2 after that. So you want to have two lists, my list 1, comma my list 2. Right? Okay. Now, now inside your for loop, where you have my list dot append appended to my list 1 dot append, right? So my list 1. Now you need exactly the same thing for the other, yeah, for the other list also. And technically you could do both in the same loop. Can we do some both in the same loop? Yeah, I think we can do. Well, I don't know. It'll be a little bit. Well, it won't be messy. It just needs a little bit of time to, like 10 or 15 seconds more to get it all in the right place. But you need exactly the same thing. Copy line 86 to 91, 86 to 91. Yeah. Yeah. Copy that, and then go and paste it at paste the whole thing. Yeah. Enter after that. Enter. Yeah. And then blank line before that. Blank line before the second for loop. And now you say line list my list 2. However, your last number should be 0 again before the start of this loop, right? So on line 92, hit enter and say last num equals 0 again, right? Hit enter one more time. Last num equals 0. Now at this point, after this, you would have two sorted lists, right? Two lists, both of which have numbers in ascending order. Yes or no? Right? Now you can confirm that before running it. Oh, did you get an error when you run it?
Yeah, because we're printing only.
Yeah, because my list doesn't exist, right? Yeah. So now copy line 101 2 times, right? Now make duplicate that line. Copy, make that two. Yeah, one more time, right? But add a yeah my list 1, and then also add a tag saying my list 1 equals, and then my list 1, right? So after cout, you say my list 1 equals within quotes. Within quotes after cout, you say the first list equals. No, within quotes you say first list equals. Yeah, first list equals. Yeah. All right. Now I know left shift after that. You know, left shift. My list 1 dot toString should be left shifted in. You need a left shift symbol after that. After left shift. There you go. Exactly. Right. Now you need the same thing for the second thing also. It's not plus equals, yeah. Okay, so if you run this now, you should see both of the lists. Why you have 9 and oh, I see. Okay, but you know what? Because you're doing a plus rand %10 or something like that. Rand %10 could be 0. So it has some places where the list is not increasing, but it's the same, plus 0. That is correct. Okay, in a real world situation, you may have in a sorted list, you may have items that are the same. That is why the mathematical term or the computer science term for a sorted list is not really a sorted list. You know, people say sort. It's not. Sort is meaning it's a non-ascending. It's just a non-descending order. It's just non-descending order, which means so now you have two lists. Now go to the end of line 102 and hit enter. Hit enter. The end of line 102. Hit enter. Okay. Hit enter. Hit enter. Now start a comment there. This is going to be homework, and you should try and do this for extra credit. Okay, this will be extra credit. If not, this is the first thing we'll do next class, and this will I can be sure that this will only take 10 minutes, and after that we can play on the game. Right? We can work on the game next class, but this will only take 10 minutes. We can either do it now, but I can see that you're getting antsy and you need to go. But so you can do this for homework unless you want to stick around and have me do this with you. I'm happy to do that. But you can do this for homework. Okay, so in the comment you say now make a new list. List 3, right? My list 3, right? Which my list 3, which contains the elements from both lists in sorted order. That's all. Okay, it's very simple. All you have to do is you got two lists, and you can look at the two lists and say, well, these are the elements of the list. You obviously, yeah, you can get the element, right? You can get the node and then node arrow data as the element, essentially, right? Or you can implement a new method. You can say get current element and it'll just return the integer. Up to you. If anything I'm saying is confusing, you just have to ask me, okay? It doesn't matter. It doesn't matter which which stage you are at. Like we know, right? Because Karthik is here from a different faculty altogether. He's not a computer science major, and then we have people who are computer science majors, and also I'm pretty sure there are people in our class who are professional programmers too, in a different language. They're doing Python and they want to learn C++. Okay, so we have in A level, 2A, 1A, 3A, we always have students spanning the entire range, from outside the department, outside the faculty, and also experts. So it's very important. If you don't understand anything at all, we can go over this in excruciating detail. Make sure you absolutely understand this. This is the cornerstone. Okay, that is why I say we have to spend as much time as possible on this. Manipulating pointers is a cornerstone, because you're going to be doing that. That's your bread and butter from now on. Right? You're going to be doing this day in and day out, to the point where you don't even think about pointers. You're just thinking about data and how it's moving around in virtual space. Yes. So that is why this needs, you spend a lot of time. Make sure, even if you know how it's done, it's just important. You just keep doing it until it's internalized. But after it's internalized, everything else will become like super duper simple. And the people who don't internalize this will find it's, lots of things are not impossible, but they're hard. And they'll be hard as long as it takes for you to internalize this. But internalizing it here in a simple context is much easier than internalizing this as part of a bigger problem, which you'll be solving. Because when you're solving a bigger problem and you need to internalize this, it's, you can't bring your mind to focus on this 100%. Now you can bring your mind to focus on this 100%. So try and do this in your own time. And you have the weekend, okay? But don't wait until the weekend. Even today, later on, you have some time. Try and do this. Make a new list. If you need, also put a comment after that. Put a new another comment after line 104. Hit enter and say, if necessary, create other simple methods. Right? If necessary, create other simple methods in the class. Okay, so that's all you need to do. And if you have any questions, you can also ask in the Reddit, saying, hey, I was trying to do what we started in class. I'm getting stuck. Can someone help me, or the prof help me? I'm happy to jump into the Reddit and say this is what needs to get done. Or if you guys want to have a separate a Zoom session, like just 6 of you, 7 of you, right, get together and say, hey, we're trying to do this, rather than do it in Reddit, can we do it in a Zoom? It's perfectly fine. Okay, and you guys choose a time. I don't have to say, well, I will do Zoom only at 12 midnight on a Thursday. No, I'm not going to do that. Okay, you say, can we do a Zoom? We talked amongst each other and we're free on Sunday at 4 p.m. Cool, no problem. Okay, unless I have another meeting at that time, I'll do the I'll walk through this code. I can do any number of classes. Okay, I told you I'm going to retire, so I can teach as much as until I get sick of teaching, which I won't get sick of teaching, but I love teaching, right? I love to get other people jazzed up about exciting things. So I'm happy to do this as long as it takes, because that is fun for me too. We're not teaching, right? What is fun for me is you getting it to work and just saying, wow, okay, like one time Omar and you guys were working on the Dancing Man and you did something and Omar said, wow, right? That is really cool. And that is what teachers look for. And to say, well, you know what, students are having fun. There's no fun for teachers to teach something that is no fun for students. Okay, it's got to be fun for everybody, otherwise no, it's not fun for anybody. Right? That is my philosophy. Okay, so it's got to be fun for you. Make it fun. If it's not fun, ask in the Reddit and say, why is it not fun? Can someone help me make it fun? Okay, and I will step in and make it fun for you guys. Is that okay with you guys? I want to leave that as a challenge. It is a challenge. Okay, it is a challenge, and it's definitely worth extra credit.
Can you share the code, Karthik? Can you share the code, Karthik, in the chat?
Oh, yeah. All right. So that's the code. All right. So are you guys okay with this? If at any time you just want me to not talk the algorithm through, but just tell you what you need to do to merge these two lists, I can do that. Well, actually, what did I say? What did I tell you? You got these two lists and we want to create a new list. Yes. All you have to do is you have the top pointer. The top is the first element. So grab onto the first elements. Okay. Now find the smallest of the first elements. That is the element that you're going to insert. Right? And then the next element you're going to insert is not going to be the top because that's been inserted. So now you're not, and don't use top. You just say P equals the top of the first list, Q equals the top of the second list. Create two new node variables, right? So P is the first one, and the C is the Q is the second one. And then after you take the first element of the P list and insert it into a new list, now your P is not the top anymore. It's, you got to say now P arrow next. Now the next time you look at the two lists, you're going to be looking at the next element there. Okay, so essentially what you're doing is walking the list. It's, you're walking the list like a zipper. You're saying these are the two elements. I'm going to say, right, I move this, and this moves forward. I move this again, so this moves forward 2 steps, and that's staying in the same place. Oh, that one needs to be moved now, so I move that now. This stays here. Okay, so you're just going to be walking like this, one of these at a time, and until you come to both lists null. Okay, by the end of the both lists, and you're done. Okay, then you have stitched up the two lists into one list that is also sorted. And the beauty of that is that happened in linear time. Okay, maybe you want to appreciate linear time and quadratic time and things like that now, but the fact that it is happening in linear time, which is proportional just to the length of the list, not the square of the length of the list and all, is a huge deal. It's a huge deal. Okay, it is basically the difference between when you go to quest, when you go to blue, green and red quests, lots of people get what is called TLEs. Okay, TLEs are time limit exceeded. So in many of the later quests, you'll have a problem and you have to solve it. If you don't solve it within a certain number of seconds, you get a TLE, meaning, oh, I got tired of waiting. You don't have any more time. Okay, and the quest fails, and that happens a lot. And the reason that happens a lot is because when there's a linear algorithm that needs to happen, the student actually use a simpler algorithm, which is easier to understand, which is not linear. Okay, and so it's not linear, and it doesn't work on the bigger projects. It works on tiny toy lists, but it doesn't work on the big data. But in the quest, I'll test these the submissions that students all this code that students submit. I test it with big ass data, like graphs of 100,000 nodes, right? And they're all interconnected in weird ways. And I throw them at the code and say, and solve this. And so and students who say, I'm going to solve this, and it works on this tiny graph that I've drawn on paper, okay? And it works. It might work on a tiny graph. I say it works on all my test cases. Oh, but you go to the 2C subreddit right now, you'll see lots and lots of posts saying, students, it works on my test case. It works on all my test cases, passes all my test cases, but it doesn't work on the questing side, right? And that's because, the algorithm is subtly different. It is slightly slower or slightly faster, and these things you'll discover later on. But by making sure that you have practice in getting to know exactly what's going on here, you'll be like super solid later on. Okay, so if you don't manage to do it, which I suspect not, I think very likely, and even it's okay with if multiple people post solutions too, right? So you can no problem. So here's a Namrata's version of merging two lists, and could be exactly the same as what Erica came up with, because it's a simple problem. I don't think there'll be multiple solutions, right? So you can all post exactly the same code too, and say different versions, and you'll all get extra credit for that. So try and do that. And say, this is how I merge two lists. And if nobody does it, then we'll do it together next Tuesday, and then move on to implementing. Next week is the last week of classes. So we'll do that as quickly as possible, and then move on to implementing that Wheel of Fortune game, which I'm still curious.
I really have to go to class right now. Karthik, could you please share the code in the chat?
Claire, press the share button and then send us that link, because you think I need to send the URL.
Oh, I just sent the URL. Whoops.
You did it once before.
Yeah, here it is.
Post it on Reddit and also put a line, just not the link alone, but just, you're sharing it here. Okay. So someone else can.
Yeah.
Yeah, all right. You need to go to class. Thank you all for hanging around, and I'll see you guys on Tuesday, okay? Bye.
I had
Thank you,
small
Karthik.
question.
Yeah, sure. Namrata.
I'm working on quest 9 actually, and it was regarding
Yeah,
that.
yeah.
So it's kind of similar in doing a linked list, but I was noticing in the function declaration, the return type is the string list star, and I was wondering what exactly that meant.
Oh, I see. Okay, all right. So here's the thing. So when you have a method and that's working on the list, And in fact, isn't that a question? And I asked that question of the spec too. Why do we return a string, a pointer, right?
Yeah.
So it's important, and because it allows you to do something very cool in the code. It's in nothing. It's just stylistic. It's just stylistic. The reason we do that is because if I call a method on a list, my list.append, but I want to append 15 elements. So my list.append number 1. Okay. Now, if I want to append 15 elements, what do I have to do? My list.append 1, my list.append 2, my list. So I have 15 statements like that. Yes. However, if you return this, then you can say my list.append 1, arrow append 2, arrow append 3, arrow append 4. So you can just basically chain all the appends to the first list because it just returns a pointer. Does that make sense? So it just allows for a nice programming pattern. In your code, it looks nice because in lots of other languages you use like JavaScript and all, this chaining is used very commonly. So you just have the object one time, you make the object once and say, call that method, and then the return type is the object itself. So you don't have to say my object dot again. So you can say, right, in this case, you're returning a pointer, not the object itself. So you have to say my object, arrow, method 1, arrow, method 1 with a different parameter, arrow, arrow, arrow. This is just say lots of arrows on. And then when a fellow programmer reads your code, they'll actually know, right? Just by looking at 15 lines, they won't have to read all of the 15 lines. They'll just know, oh, yeah, that's what it's doing.
Yeah.
That
and
doesn't
then-
make sense?
Yeah, I get like why we do it. I was just like kind of confused, like what would we would actually like return, because like when we're just like
yeah.
writing
Yeah. So my list is actually an object, isn't it? So it is stored somewhere in memory. If it's an object, it has to be stored in memory. So if it is stored in memory, it has an address where it starts.
Yeah.
This is that address.
But like, would we create my list in main, because this is just like in the function, right? Because we're not creating we're not creating the
No,
list like
my
in
list
it.
is not created in main. My list is created in the constructor. The main says, I want to call the constructor for main. Now, call the constructor for main, my list, right? That's what you're doing, right? You're calling constructor in main.
Oh, so in the constructor we have to do like new string list.
No. In the constructor, you do what you're doing now. In the constructor, all you have to do is inside the constructor, when you, in your main, you do my list. And so different constructors do it different way. There are different ways. So in your main, if you say list my list, if you say list my list, right, that automatically calls the constructor. Even though you're not saying my list equals construct my list, it calls the implicit constructor. So your list has been created in memory automatically at that point, right? In this case, because your list is going to be on stack, it's not on heap, because you're not doing my list. You're not saying my list equals new list. You're just saying my list. Yes.
Yeah.
So it's not on heap. So it's right there. Nevertheless, it has a memory address. It's stored, right? It's an object. It has a memory address. Now, every time any method of the list is called, has to be a method of the list. You can't call an arbitrary method. So arbitrary function doesn't have a this. If you call a method of that object, inside of that method, there is this hidden parameter called this. There's a hidden parameter called this, and this is always going to be, the value of this is always the start address of the object.
Oh,
It's a
so-
hidden parameter. Yeah.
Mm.
In
So
fact,
you
you know,
would like you would return this dot like string list?
no, you say return this.
Oh, okay.
Because you just want to return the address. You want to say,
Oh.
I've done something to an object, and the place where the object starts is this address, and you just return this.
Oh, okay.
It doesn't make sense?
Yeah.
It's actually really cool. It is really cool. Okay, so once you understand what's going on, you'll be using it everywhere. Okay, you're gonna be because it condenses your code too, right? You don't have to type mylist dot mylist dot mylist arrow. You don't have to type it like 15 times, right? You can just say arrow. It is especially helpful, I think, when you later on in Graph Quest, right? In Quest 9, the last quest of Red. People have to construct graphs, and they have to debug graph algorithms. So they're when they're debugging graph algorithms, they're creating their own graphs. So they start with a null graph and they add an edge to it. But my graphs are like huge. But the students, when they test the algorithms, they're not going to use huge graphs, but still their graphs will have 50 or 80 edges or something like that, 100 edges, right? So instead of saying my graph dot add add this edge. My graph dot add that edge. They basically just say my graph dot and then add edge 1, add edge 2, add edge 3, add edge 4. They just, and then it's very clear for the debugging, right? It's a lot easier for debugging that way. And that pattern, that is a nice pattern. Okay, that is a nice pattern. When you get used to it, you'll find the same pattern in other languages. Okay, do you know JavaScript in other languages or any other languages?
Yeah, I've done Java and I'm doing Python and
Java and Python. Okay, yeah. Yeah, hey, Java, I'm pretty sure I've seen this pattern in Java a lot. Okay, in Java, people use this pattern a lot because, especially in Java, there is no distinction between dot and arrow. There's no arrow in Java, right? Because everything is an object and everything gets point. So, so people actually just return this in Java. Return this in Java, and then in your method, you can just say dot 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 for everything, and it's a very nice pattern.
okay. Yeah, that makes sense. Thank you.
All right. Okay. Cool. All right, thank you guys for hanging around. I'll see you guys on Tuesday, and I hope to, and I'm looking forward to seeing your code. Okay, it doesn't matter even if it doesn't work. You can just post it and say, hey, why doesn't it work? All right, see you guys later. Bye.